All right, let's talk about a homework question that was asked in class that we didn't have time to finish. So this was on page 60. This is in your handout package from week one. And the question was just on the interpretation of this isometric. Okay, so the arrow is pointing at what the book is choosing arbitrarily to be the front view. And your job is to look at all of these views and identify which one of these is the front, which one of these is the right side, and if I carry on here, which one is the top, left, bottom, and rear view. So let's have a look. What I've done is I've drawn the 3D model of this component right here. And so let's just kind of peruse this. So the book has said, hey, make this feature here, make this the front. This is the front. So that if this is the front, then this is the right side. This is looking down at the top, and I'll just highlight the top in red. So this is all seen from the top view. That's top, and then this is left, rear, and then bottom. So let's just cruise around, look at the model. There's our front. That's what we would see with the human eye, the naked eye. We wouldn't see any hidden features. We would just see the lines that make up the visible lines. There we go. There's the rear. There's the left side. And we're back to the front. Please, as I said in class, ignore this. This is my view cube in CAD, and it doesn't correspond to the views the book has chosen. The book said this is the front, okay? So just ignore that. And now the bottom is essentially going to be this view right here. So when we look at engineering drawings, we look at orthographic views, what we have to do is actually account for the hidden features. So any line that we can't see with the naked eye but is on another plane has to be shown as a hidden feature. So in the case of this bottom view, there would be a hidden feature right about here. Okay. And then we would have a hidden feature representing this line. So let's just go to my view that I'm going to draw for you here. I'll make this a smaller scale so we can show all the views, and you can see basically the solution. So I'll put the isometric over here for reference, and then what I'll do is I'll project the other views. So I've got, there's the left, there's the bottom. Okay, create that. So let's just move this around so I can show the rear, and I'll just project the rear from the left side view. So there's the rear. So again, any feature that can't be seen with the naked eye when looking at a view is going to be accounted for as a hidden line. Okay, so let me just label these real quick with my screen drawing tool. This is going to be front. This is the right. I'll just put RS. This is the rear. This one's the bottom. This is the left side. Sorry, not the rear. This is the top. All right. You would have corrected me in class, so that's the top, and this is the rear right here. So there's essentially your solution. So you're going to just place yourself with respect to the object and imagine which lines would you see without Superman X-ray vision, and then the lines that you wouldn't be able to see because you don't have Superman X-ray vision, you're going to represent with hidden lines. Okay? So I hope this video helps with the interpretation of the homework problem that was assigned in week 1 on page 60 in unit 3. So again, here's another spin around looking at the model, and perhaps I can look at this with wireframe mode. Maybe this will help your understanding as well. So here, wait a minute. Let's do it this way. So here, I can see there are no hidden features in this case. As I rotate the model around, looking at the front, there's no hidden features. When I look at the left, okay, I have some hidden features because I have this line to take care of. When I look at the bottom, this is what I have. So again, a question in class was, okay, how do I know which way to orientate the bottom, say? Well, again, if this is our front view, the other views we can think of this thing being in a glass box like so. There it is. And we think of this glass box as being hinged, okay, with respect to the front view. So this bottom flap would hinge right here and would be arranged in such a way, okay? So it would be like this. This is what we would see. So here's the front, and it's pivoting on this edge here. So it's going to look like this. Okay? And there's the proof right here on the layout drawing. But I can kind of animate it for you where there's our front, what we've chosen to be the front, and if I rotate this about this line right here, this front edge, where the bottom meets the front, if I continue to spin this along about that edge, there's my bottom view. Okay, so I hope this video helped and look forward to seeing you all in our next class. Take care, everybody.